We are only in the second half of April 2026, and AI has already dropped a strangely coherent batch of releases. Alibaba released Qwen 3.6, Moonshot released Kimi K26, OpenAI pushed GPT Image 2, Google introduced design.md, and Anthropic managed to trigger a developer backlash over cloud pricing that said as much about infrastructure economics as it did about subscriptions. At first glance, those look like separate product updates. One is about open models, one is about swarms, one is about images, one is about UI specification, one is about pricing. But taken together, they describe the same trend surprisingly well, and the Kimi K26 release is probably the clearest competitive signal in the batch. What makes it interesting is not just that Kimi added swarm mechanics or long horizon execution, it is that an open model is now pressing much closer to the benchmark space that closed vendors have used to justify their premium position. AI is becoming less about single replies and more about systems that can keep working. That means longer context, more tool use, more parallel workers, more multimodal handoffs, more persistent state, and much more visible compute cost. The center of gravity is moving away from the isolated answer and toward the quality of the loop around it. That is what I mean by the orchestration era. Look across the releases that define the month and the pattern becomes hard to miss. Alibaba pushed the open frontier outward with Qwen 3.6. Moonshot pushed horizontal scaling and swarm endurance with Kimi K26. OpenAI improved visual generation by giving the system more deliberate planning time before rendering. Google tried to turn design intent itself into a durable machine-readable contract. Anthropic, meanwhile, ran headfirst into the economic consequence of autonomous coding loops and revealed just how different agent workloads are from normal chat consumption. These are not disconnected product stories, they are all reactions to the same pressure. Models now operate across longer horizons, tasks increasingly span many files, tools, and modalities. Users want persistent execution instead of one-shot assistance, and the infrastructure cost of autonomy is much higher than the old subscription assumptions allowed. The important transition is conceptual. The fundamental unit of compute is no longer just the prompt response pair, it is the loop. Qwen 3.6 matters because it weakens one of the strongest assumptions from the previous cycle, that the best agentic coding workflows would remain structurally tied to closed models. The release pushed several things forward at once. First, the giant context window changed what local or cost-optimized systems can attempt. Once a model can hold an enormous slice of a repository in working memory, the experience shifts from fragmented retrieval toward repository-level reasoning. Second, the multimodal improvements matter in a more practical way than benchmark language usually suggests. A model that can read a UI screenshot, infer component relationships, reason about layout, and then convert that understanding into code is participating in the entire design to implementation chain. Third, the sparse mixture of experts configuration is strategically important. If a model can activate a relatively small slice of a larger expert system and still hold up under real coding tasks, then the economics of local or semi-local orchestration become much more favorable. That changes the market. Open-weight models are no longer just fallback options or hobbyist substitutes. They are increasingly credible building blocks for serious agentic systems. If Qwen 3.6 expands what one open model can do, Kimi K2.6 is the sharper competitive statement. It is the release that most clearly says open source or open weights can no longer be dismissed as the cheaper lane beneath the real frontier. The headline is not simply that Kimi has swarm mechanics, it is that Kimi K2.6 paired those mechanics with benchmark results that put an open model much closer to Claude Opus and GPT 5.4 territory than the closed side would probably like. That changes the tone of the market. The question is no longer whether open systems can be interesting, it is whether closed systems can keep claiming that the real frontier is safely out of reach. The interesting part is not only the model scale or the benchmark scores, though, it is also the topology. Kimi K2.6 pushes the idea that the real breakthrough is not one giant inference pass, but a system that can decompose a problem into a large number of specialized workers, run them in parallel, and then synthesize the result coherently. That is a different product shape. The move from 100 agent coordination toward 300 agent swarms and thousands of coordinated steps matters because it reframes what developers are buying. They are not just buying a model that is good at coding, they are buying a system that can sustain a long-running campaign of work, search, compare, refactor, test, diagnose, retry, document, and keep going. That is exactly why the benchmark positioning matters so much. If an open model can stay competitive while also representing a different licensing and deployment story, then it starts to pressure the entire closed model pricing narrative. Kimi does not need to beat everything to matter, it only needs to become credible enough that choosing Claude Opus or GPT 5.4 feels like a trade-off rather than an automatic conclusion. This is why the phrase long horizon coding feels more accurate than most of the older copiloting language. A swarm can operate like a temporary organization. The challenge stops being whether the model can generate a plausible patch. The challenge becomes whether the system can keep many patches, validations, and sub-goals aligned over time. That shift is bigger than a single release. It implies that orchestration logic itself becomes a first-class engineering discipline. Delegation strategy, worker specialization, memory boundaries, callback contracts, verification gates, and failure recovery are all now part of the product surface. One of the clearest signals in the month did not come from a benchmark. It came from pricing friction. Anthropic's Claude Pro controversy made visible something the market had been able to blur when usage was lighter. Flat rate subscriptions do not map cleanly to recursive autonomous execution. That makes intuitive sense once you stop comparing agent workflows to chat sessions. A bounded conversation has a predictable envelope, a long-running coding agent does not. It repeatedly rereads context, generates output, runs tools, ingests failures, replans, and continues. What looks like one user request can become hundreds of internal calls and a very large amount of process state. So the Claude Pro backlash was not just a pricing story, it was a signal that the business model from the chat era is structurally misaligned with the orchestration era. If an agent can run like an always-on process, then the provider is effectively underwriting a dynamic compute workload, not a tidy monthly conversation allotment. The deeper consequence is market migration. Once developers feel that autonomous workflows are being artificially gated behind steep subscription jumps, open weight and API-driven alternatives immediately become more attractive. Cost transparency starts to matter almost as much as capability. That is why the pricing story belongs inside the technology story. Economics is now part of model architecture selection. One of the most interesting convergences in April 2026 happened in the visual layer. OpenAI's GPT-Image 2 pushes visual generation toward more deliberate planning. Google's design.md pushes UI generation toward more explicit rules. On the surface, those feel like different philosophies, but both are closing the same gap. The historical divide between design intent and executable implementation. GPT-Image 2 matters because it makes visual generation look less like vague image synthesis and more like a constrained reasoning problem. If the system can spend extra compute planning layout, typography, hierarchy, and text placement before rendering, then UI mockups stop being decorative artifacts and start becoming structurally useful planning objects. Design.md matters for the opposite reason. It treats design as durable specification. Instead of inferring taste from a prompt every time, the agent inherits a structured contract containing tokens, component rules, and the semantic rationale behind the aesthetic system. Together, they point toward a future where the visual layer is no longer a separate handoff domain. The system can ingest a design specification, generate or review the visual output, and then implement the interface code in the same operational loop. That is a major change. It means the distance between mockup design system and shippable UI is collapsing. The optimistic read of orchestration is easy to understand. More delegation, more throughput, faster iteration, fewer manual bottlenecks. But the same shift also expands the failure surface. Once a system can coordinate many workers over thousands of steps, small errors have more room to compound. Tool misuse, weak verification, hallucinated assumptions, stale shared state, and brittle handoffs become structural risks rather than edge cases. The system does not merely answer incorrectly, it can act incorrectly for longer. That is why the safety discussion around emergent behavior, shutdown resistance, hidden coordination, or high-risk self-preservation is no longer purely academic. Even if most production failures remain far more mundane than those research scenarios, the engineering lesson is already clear. Orchestration without strong boundaries is dangerous. In practice, that raises the value of boring things. Deterministic tests, explicit ownership boundaries, human approval gates, short callback vocabularies, artifact validation, and stop-the-line behavior when confidence collapses. The more agency the system has, the less optional those disciplines become. If the orchestration era is real, then the engineer's role keeps moving upward in the stack. The scarce skill is less about writing each line manually and more about shaping the environment in which generated work stays coherent. That means better decomposition, clearer contracts, stronger tests, cleaner interfaces between workers, and better judgment about where determinism should end and open-ended agent behavior should begin. The old question was, which model is smartest? The newer questions look more like this. Which model or mix of models is appropriate for each layer? What should be deterministic versus agentic? How is context preserved across long horizons? Where are the verification gates? What does the cost curve look like when the workflow runs recursively? That is a different craft than prompt tinkering. It is closer to systems design, operations, and product architecture fused together. The strongest lesson I take from April 2026 is that intelligence is becoming easier to source than orchestration quality. Open models are getting stronger. Closed models are still powerful. Visual generation is improving. UI intent is becoming more machine readable. But the durable value is increasingly in how these capabilities are composed, who delegates, who verifies, who owns each artifact, how costs are controlled, and how the whole loop stays legible under pressure. That is why the market feels different now. We are no longer just comparing answers, we are comparing operating systems for autonomous work. And that is what makes April 2026 feel like a boundary line, not the month AI got smarter in the abstract, but the month the industry more openly reorganized around orchestration as the real product.